In Module 1, you learned about the normal distribution, which is a tool that we use in statistics, and you will continue to see it show up later, even in Module 2. The first part of Module 2, we're going to talk about some terminology and some other ideas about statistics that we need to understand before we can go into analyzing the data. So on that note, one of the first things we want to talk about is what is data? Well, data is going to be values, and this can be either numeric or non-numeric. With context and meaning. And it's that last part, with context and meaning, that is very important to us in statistics. Because if we don't know what those values represent, there is really no point in us getting those values. So as we dive into getting data, one of the first things that we need to know about is why we want to collect our data. So the first definition we're going to talk about here is what's called a parameter. A parameter is a numerical summary of the sample. A numerical summary of the population. I was jumping ahead. And so this is generally something that we would like to know. So maybe I would like to know what percent of all students pass this course. So it's a number that I want to know about a big group. What a statistic is very similar. It is a numerical summary of the sample. And so since these are not very different from each other, the easiest way to remember the difference is paying attention to our first letter. So both parameter and population start with P, and statistic and sample both start with S. So that's one of the easier ways to remember which one is which. Now that we know why we want to collect our data, we want to figure out who are we going to collect this data on. So our first definition here is what's called an experimental unit. This is the individual that a record comes from. So a lot of times this can be a person, it could be a plot of land, it could be an animal, but it's just that individual thing, which again could be a person, that you collect data on. So once we know that type, we can figure out who our population is. And our population is the entire set of all possible experimental units that we're interested in. This could be something quite large, like every single person in the United States. It could be something a little bit smaller, like every person in our class. So populations can be very different sizes. And then once we know the population, we can figure out who our sample is. Our sample is ones that we actually collect data on. So although I might be interested in all people in the United States, I'm probably not going to get information on every single person in the United States. So I might only get a few of those people, and those people would be my sample. All right. Now we know who we're going to sample. Now we know, well, what information do we want to get from our experimental units? So the first idea we have is the information that we collect is what's called an variable. So this is the information collected on an individual experimental unit. And there are a couple different types of variables that we can collect information about. One is called a categorical variable. This is also sometimes referred to as a qualitative variable, but I have the tendency to use categorical because you can, one, hear our distinguishment between categorical and our second one, quantitative, much better than between qualitative and quantitative. And secondly, because its definition is very helpful and very informative. It is a variable whose responses consist of category. And we will go through a couple of examples of these, but we're going to talk about the other type of variable first. So we can figure out when I give you a variable which one it is. So a quantitative variable is a variable whose responses consist of numerical values. But we're going to add a little bit to that. So again, numerical values. But these numerical values quantify or measure something. And so we'll talk about that distinguishment of what numbers are quantitative versus what type of numbers are actually categorical. So let's start looking through a couple of examples. So if I was recording someone's gender, would that be categorical or quantitative? Well, you're either male or female, so that's going to fall under a categorical option. Versus instead, if I was recording someone's height, so how many inches tall are you, that's going to fall under a quantitative variable. Because if I'm 64 inches tall and you're 67 inches tall, I can tell that you are 3 inches taller than me. So that's measuring something. So that's what we mean by that, quantify or measure something. All right, another example might be age. Where do you think age would fall? Well, again, age is a number. It does actually quantify. So if one person is 25 and someone else is 30, I know that that person is 5 years older than the other person. All right, how about your major? All right, so major would be categorical that we're looking at there. All right, how about your area code? So if you think for a moment, what would you give me as your area code? Right, you're going to give me a number. So for example, it might be 859. Right, but what does that number actually tell you? It tells you someone's geographic location. So even though it is a number, it really is actually categorical. And so to understand this idea of what it means to quantify or measure something, and it might seem like a silly example, but I originally came from Nebraska, and my area code there was 402. And then I moved to Kentucky, and my area code became 859, which is more than double what it was before. Does it really make sense for me to talk about my area code doubling? Does that really quantify or measure something? Not really. So that's going to be a categorical variable instead. Now for a lot of students, that part seems pretty easy, distinguishing between a categorical and a quantitative variable. Keep that in mind as we continue throughout the modules. Because as we move from module to module, it's just what variable we're working with Is it categorical or is it quantitative? And then if we're working with one or two variables. And so that's really what drives what we're doing, is based upon how many variables and what type they are. Right. Other things that we would like to know, if possible. We would like to know where the data came from. So for example, if we were looking at United States salaries versus Mexico salaries, that makes a pretty big difference to me. So I'd like to know that information. When, if we were looking at gas prices in 2005 versus in 2015, that's going to be very different. So I'd like to know when the data was collected, if possible. And finally, I'd like to know, how did they get the data? So not only how did I get the data, for example, from the person or from a computer database, but also how did I pick those specific people or elements to be in my sample. So for example, if I was looking at getting someone's salary, if I ask someone in person versus get that from a database, I'm probably going to get two very different numbers. And so making sure we get accurate data, but then also how did we pick those people is going to be important. So before we go on to anything new, we're going to just take the idea of the terminology that we've learned so far and apply it to a couple of problems. So in our first example, we're interested in estimating the mean age of all undergraduate students at NKU. So I took a random sample of 100 undergraduates at NKU and recorded their age. So that's just our little setup, and then we're going to talk about some of the terminology applied here. So if I was to look at this example, who is my population? I pretty much have it right here. Right, I am interested in all undergraduate students at NKU. I don't want to look at a graduate student. I don't want to include faculty. NKU versus other universities could be different. And so I am bringing pretty specific here of looking at all undergraduate students at NKU. Right, now that we know who we're studying, we want to figure out what information we're getting from these people. So what is my variable of interest? So what do I want to get from them? Well, I want to get their age. And so is that going to be a quantitative or categorical variable? Well, it was one of the examples that we used here. So this is actually a quantitative variable. Now going back and looking at parameter. So a parameter was the numerical summary of the population. So it's a number I want to know about my population. So what number do I want to know? I want to know their mean age. So this would be our population mean age. I could have also just said the mean age of all undergraduate students at NKU, and that would be perfectly fine because I defined my population that way as well. All right, how about the statistic? So the statistic is different than a parameter as to where it comes from. So it's from the sample instead. So I know this is going to start with sample. But what number can I get from my sample? Well, my sample is the 100 undergraduates at NKU. I'm also recording their age, so I could also record their mean age. So that's what it looks like to apply our terminology to this first problem. Before we move on to the second example, I just want to look at some symbols that you're going to see throughout our course. Now, when we talked about the normal distribution, you saw this Greek letter mu that represented the population mean. So that's what we're going to use here for our population mean. But up until this point, that's the only symbol you've seen for a mean. We want to make sure we distinguish when I have the the entire population versus when I only have a sample. So how do I know when I only have my sample? Well, here, if I only had my 100 undergrads at NKU, that would be my sample. So I want you to know when I have that. So we use a different symbol. So we have this Y with a bar on the top, which we read as Y bar, and that's just going to represent the sample mean. Right, looking at example 2, I'd like you to pause the video here and then try to get through the population, the variable, the parameter, and the statistic, and then unpause the video and see if we agree. Now generally for most students, this is about where we get before we feel a little confused on numbers 3 and 4. So usually we do pretty good with getting at the population as all Americans. We do pretty good at getting at the variable is whether they approve or not. How you phrase that might be a little different than mine. So I just have approval, which is a yes or no type of question. So it's going to be a categorical variable. Now usually once we get to parameter and statistic, we're a little bit more confused. So the parameter is going to start with a population, and the statistic is going to start with the sample. So the population, what is going to be my parameter? Well, it's going to be a number from the population. So we're going to have the population approval percentage. And then same idea for the statistic. It's going to be the sample approval percentage. So finally, to end this video, we're going to talk about some questions I have for you to understand where we are going. Let's see, before we do that, let me give you 2 new symbols that you're going to see a lot in the rest of this module as well as in the next couple of modules after. So you notice here we're not talking about means anymore, so we can't use the same symbols that we had on the previous page. We're going to have P to represent our population proportion. And then P hat is going to be our sample proportion. All right, so my questions for you, we're going to use this example that we see here. So suppose we each sample 1,000 Americans. So you go out and get 1,000 people, I go out and get 1,000 people. We're going to look at us each doing that. So my first question is, would we each get the same P hat? So are we going to all get the same sample approval percentage? So if I were to find that 47% of my sample approved, would you find that 47% of your sample approved, or could you get different numbers? Right? We're all not going to get the same value for P hat. We could, but not very likely to happen because we're sampling different people. Second question is, would we each have the same P? So would we all have the same population proportion? Well, technically yes. We're all trying to get at that population approval percentage, but because we're taking different samples, we can get different values. So sort of the takeaway from this is that parameters, or population values, are fixed, versus statistics, or our sample values, vary based on the sample selected. And so a nice idea to think about with that is many of you have probably seen the jar of jelly beans and guess how many jelly beans are in the jar type question. Right, so P is like how many jelly beans are in the jar. There is a certain number. We're all trying to get at that same number. But each of us is going to make our own guess, which are not going to be the same. So, right, our values are allowed to be different. And so based upon who we sample, we can get a different number. In the next video, we're going to talk about actually how to take these samples.